Hi and welcome to video 11 on this video series on perpetuities, and from the annuities topic. This is topic 1 unit 4 of the general math curriculum, and so I'm going to be looking at an example which I've put here is complex familiar question mark, and it really probably isn't, but I've done it deliberately because I'm going to look at two examples in this video, and the second one is example 1 but made a little bit more complex familiar. So I'm leading you through it. Expect to see the second example as a more common case of a complex unfamiliar question in this perpetuities topic. Annika begins an annuity with $12,000 and invests $200 per week for 20 years. At the conclusion of the investment, she hopes to live off this annuity as a perpetuity. If her investment can earn an average of 8% per annum, compounded weekly, how much money would she withdraw each week in retirement? So it's sometimes worth trying to diagram this type of model up, and we're talking about retirement. So first of all, we've got a deposit annuity, and so our first phase is this growing annuity here, and our second phase is a perpetuity. We're hoping to live off that. So in our first phase, I know that I is equal to 8% over 5,200 because I is a weekly rate in this calculation. We also know that she's depositing, she starts with P equals $12,000, that's what she starts with, and then she's depositing regularly, which is our M in our formula. I'm just trying to recall the formula stuff. Our M is 200, there we go, and our N is equal to 20 years but times by 52 because there's 52 weeks in a year and we are working weekly here. Now, once I've done this, I'm going to calculate my A value. I'll just write the formula over here to remind you. Remember, A is equal to P times 1 plus I to the power of N, plus, because it's deposit phase, M times 1 plus I to the power of N minus 1 over I, close brackets. And of course, this is our pretty much most complex formula in annuities. It's not on the formula sheet, but this is on the formula sheet, and this is on the formula sheet. And so just remember, this represents the compounding value of our initial investment after n time periods, and this represents the growth value of our regular investment after 20 years. So you've got those two formulas, you just have to combine them because we have an initial investment and we have a regular investment. So that's where the complexity comes from. Once I've got the A value though, this will be our P value in our perpetuity, because it's A because it's the end of our investment for our original one, and it becomes P because it's the start of our perpetuity. But our perpetuity remains flat anyway, and I is equal to 8 over 5,200, and we'll know our P, and then we'll be looking for our D. Once we have our D, that will be the weekly regular payment that we can get. So let's calculate our A first of all. A in the original case will be 12,000 times by 1 plus I, I'm substituting in, 1 plus 8 over 5,200 to the power of 1,040, because 20 times 52 is 1,040, plus 200 times by 1 plus 8 over 5,200 to the power of 1,040 minus 1, and I'll just put brackets around this, over 8 over 5,200. And when I calculate this, it comes out as a pretty big number, 572466.3848, which rounds financially to 572,466.38. So that's our two decimal places. I have maintained accuracy here by using fractions, and I've maintained accuracy by keeping this number in my calculator. So I'll be using that number for my next calculation rather than rounding it even to 4 decimal places. I'll be keeping it in the calculator. Now the second part of this is my perpetuity. So we know our P value. So I'll just do this now. That is our P value, and we know our I value. That's our value up here. And so our perpetuity says that D is equal to 572,466.38, but remember I've kept that value in my calculator, multiplied by I, which is 8 over 5200, and so the value I get out of my calculator with those correct calculator values is 880.717 0.51, and so on, and that's equal to $880.72. $880.72. But of course, keep in mind in this particular question, how much can she withdraw each week after her retirement? Now, I've rounded this up. Oh, that's going to be funny, sorry. I've rounded this value up, and that means that actually she'll be drawing money out of her account. It'll be dropping in value. So we're actually better off rounding down in this context. So I'm going to say my final answer is 880.71, and it's definitely worth you explaining that decision in an external exam situation. I'm rounding down because blah, blah, blah. So that's the first part, the part that I'm claiming to be complex unfamiliar, complex familiar, but what I'm going to talk to you about now is the second part, which is probably a little bit more complex unfamiliar. Let's have a look. Annika hopes to retire in 20 years and will need $1,000 per week to live off comfortably from a perpetuity. If she currently has $1,200 to start an annuity and plans to invest $200 per week, her investment's earning her 8% per annum compounded weekly, and then after 8 years, Annika inherits a lump sum of money. How much money must she invest or inherit in order to meet her goal of retiring with $1,000 per week? So we wouldn't normally have these two questions back to back, but we do. And at the moment she's getting 880. So whatever it is the extra that she has to invest after 8 years has to be enough to cover the final 120 that she doesn't currently have. So we know that. So let's draw a little diagram to have a look at this. My diagram this time looks like this. We've got a growth-based annuity, but it stops here. And that's 8 years in. After 8 years, we get a lump sum payment, and we don't know what that lump sum payment is, so I'll call it L. And then we've got a growth-based annuity again from there. And it takes us to here, and then we've got a perpetuity, which is flat, and that perpetuity, we have D is equal to $1,000. So this time we know our D value. And then we also know our I value, which is 8 over 5,200. So let's have a look at how we might work this out. If I'm going to mud map it, as with the previous question, I've got all the information here to do my calculations. If I'm going to mud map it, as with the previous question, I've got all my information here to do my calculations for the first 8 years. I also now have all my information here to do my calculation to determine the P that I require to have a perpetuity that will successfully give me $1,000 per week. So I can get my A value to here, and I can get my P value to there. Now, if I've got my P value here and I know everything else about the situation, well, then I can work out my P value here. So this is called A there. I can work out the initial deposit that I'll need here to make that work. I'll know the A value there, and the lump sum required will be the difference between that P and A. That will be the immediate lump sum that I need to calculate. Now, keep in mind this investment happens for 20 years, so this is a 12-year investment, and everything's going to work weekly. So let's have a look at our situation then. Let's start by creating a little bit more space, perhaps. Let's start by considering and working backwards in this stage 1. So I'll call this stage 1. So in stage 1, it's a perpetuity, and P is equal to D over I. And so that's equal to 1,000 over 8 over 5,200, which comes out as something nice and simple, I think. There we go, 650,000. So we need $650,000 at the end. Now, we also know, I'm not going to do this working again, so we'll call this stage 2. We also know, I'm going to just change this up a little bit because of our work that we've done, that if she invests, a P is 12,000, and she invests M is $200 per week, with I equal to 8 over 5,200. It's not a very good fraction bar. And N equal to 20 years times by 52, well then I can actually calculate what it's worth at the end of 20 years. So I'll show you my little change here in a second. But from our last question, we know that A was equal to 572466.38. And so actually what this means is that this growth to here is 5724 5724.66. Sorry, 572466.38. And up here, we've got a p-value of 650,000. So we can get our difference here. That's what the lump sum needs to be worth there. So I can say L12 is equal to 650,000 minus 572,466.38, and that's equal to 77,533.62. So because of my previous example, this is going to be the easiest way to do it, but the original way I mapped out would also work and would probably be quicker without the previous example. This is the tricky bit here that you need to really think about. I know my lump sum and I know what it needs to be worth after 12 years. So that's why I've called it L12. After 12 years of compounding, it needs to be worth $77,533.62. So what is the lump sum I need at the start to make that happen? Well, I'm not investing regularly, so this is now the this is the A value required in a simple compound interest formula, where I is also 8 over 5200, that's consistent, and N equals 12 years times by 52 because we're talking about weekly. And so I'm going to put this into my calculator to determine the P value in this formula. A equals P 1 plus I to the power of N, and that will backtrack the value of that money to when I started. What P value did I need to invest in a compound interest account at that interest rate for that number of years to determine to get an A value of 77,533.62? That's the question. And so I'll rearrange this quickly now. P is equal to A over 1 plus I to the power of N, and that's equal to 77,533.62. But I will mention here I am maintaining accuracy, so if you need to, write down 6, 7, 8 decimal places. If you can't manage to keep it in your calculator, write down as many as you can. And 1 plus I, that's more like a T, which is 8 over 5,200 to the power of 12 times 52. And the answer, keep in mind, it should be less than 77,000. I don't expect it to be significantly less, but it is 12 years weekly at a pretty high rate, and it comes out at 29,708.98. Now again, I've rounded that and I have rounded it up. Keep in mind, if I want to achieve this, I need to be rounding up at the right times now, otherwise I won't have enough at the end. And then when I'm withdrawing, I need to be rounding down to make sure that I maintain that amount. So it's all in context here. So I will require, or Annika will require, after 8 years, she inherits some money, and the amount she needs to invest of that inheritance, hopefully it's enough, is $29,708.98, which will guarantee that after a further 12 years, when she retires, she will have $650 in her perpetuity and be able to draw from that $1,000 per week. So that was a pretty tough question and involves a bit of thinking. I hope that you take from this the idea of this diagram and using a diagram to support your understanding and mud map your way through a question. It is a really good way to do it. And perhaps you've experienced seeing a bit more of a complex question. So we're finished now this unit and this particular topic. So hopefully it's helped. And for this particular topic and area of perpetuities, I'm hoping you can now describe an annuity or perpetuity that you can calculate withdrawals, interest rates, and investment amounts required to meet needs, and you can interpret and solve more complex annuity problems. All the best.